Our lesson today is about angle relationships. If you hear the word relationship, what can you think of? Yeah. So maybe you might be thinking of boyfriend and a girlfriend. That's another type of relationship, right? We have friends. That's another type of relationship. Then we have classmates, classmates. So that's another relationship. It can be considered also as a relationship. Okay. Then we have your brothers and your sisters and your parents. Family is also a relationship. And so uh, uh, we'll be able uh, to distinguish how are we related to this person, and our behavior is also uh, will depend also on the type of relationships that we have, right? So we'll not be going into details of those relationships one by one, because our main topic is about angle relationships, about geometry. So these are relationship that exists between two given angles. So most of the times we're just talking about two angles and the relationship that exists. Then, but it can be more than two angles depending on the type of relationship. Some relationships only involves two. Some relationship can have more than two. Okay, like the usual that we have. If it's family, it can be more than two people involved in that kind of group, in that kind of relationship. But if it's something intimate, husband and wife, it should only be two. If it becomes three, it's gonna be a big problem. If it's boyfriend girlfriend, just between the two of you. If there's another one that is involved, like big problem. Okay, so sometimes we need to know what's the limitation and what's the rule in a particular relationship, even in these angle relationships that we're going to discuss. Okay, so here we'll be talking about 6 relationships. We have adjacent angles, vertical angles, linear pair, complementary angles, supplementary angles, and perpendicular angles. Okay, so those are the relationships that we have. So let's start with adjacent angles. Okay. Pairs of angles are certain pairs of angles have special names. Okay. So adjacent angles. What is an adjacent angle? So these are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. So we have a group of examples of adjacent angles and non-examples of adjacent uh, angles. So we have here, we have first, we have angle ABC and angle CBD. So angle ABC and angle CBD. Okay, we already talked about naming an angle. So we should be able to identify which angle are we talking about. When we say angle ABC, this angle over here. From this side, from ray BA to ray BC, so this opening over here, that's the angle form. Okay, that's the wideness over here, that's the angle that we are talking about. And then angle CBD is the angle from ray BC to ray BD, so this angle over here. So adjacent means two angles are next to each other. There's just one side separating them. There's a common, it's like common wall between them. So these two pairs, this pair of angles are considered as adjacent angles. Okay, it's just like classroom. There's no part of there's in a classroom, it is separated with a wall. In most of the classrooms that we have, there's nothing in the other classroom that is common, that is wherein we have an access to from the other classroom, right? So there is a common wall, although there are some parts that it seems that it's already in our floor, but we cannot have access to that classroom. Okay, so there is a common wall, so that is adjacent. So when we say, where is your class? It's adjacent to teacher Arnell's class, or it's adjacent to teacher Bruce's class. So that's how we use the word adjacent if we're gonna describe a location, also just next to each other. Which store? Oh, the store adjacent to Budget Mart. So you're referring to the other store closer or next to that particular store. Okay, that is adjacent angle. Next, we have vertical angles. I mean, this other group are non-example. Why is it this ABC? This one looks like adjacent, but why it's under non-examples? Because when you look at the name, it says ABC and ABD. ABC and the whole thing ABD, not because there's already, if you say ABD, it's also including ABC. So when we say adjacent, it should be independent, not including other parts of uh, the other angle. So if it's ABD, it's also including the ABC. So that's why it's not considered non-example based on this pairing. Okay, here ABC and BCD, ABC, BCD, that's not an angle because obviously another thing that you need to look at, they must have a common vertex. The vertex here, which refers to the second letter, the middle letter is B. The vertex here is the middle letter, which is C. So that's not considered as adjacent angle. The middle letters must also be the same, okay? And that they don't overlap each other. There's no common interior points between two angles. So ABC and CBD can be examples of adjacent angles. Next, vertical angles are two non-adjacent, so it's very specific. Two non-adjacent angles formed by intersecting lines. So you can only have vertical angles if there are two lines that intersect. Okay, when you say intersect, it must cross all the way to the other side of the other line. For example, this is the line DB. Okay, if this is line DB, for you to have a vertical angle, this line must go all the way. That's why it goes all the way past E all the way to C. So you have line A, C. It doesn't just stop in here. If it stopped in here like this one, it's not considered as vertical angle. I mean, you don't have any vertical angles here unless this line goes all the way to the other side, then you can create. Or this line goes to the other side, then there is an existing vertical angles in there. But since no line intersects the other line here, so we cannot have an vertical angles here. So only this one has vertical angles. So again, it's non-adjacent. So when you pair them, when you pair vertical angles, then you don't pair the angle next to the other, okay? Because if you say angle AEB, okay, this is angle AEB. If you say angle AEB and angle BEC, no, you are pairing them like they are adjacent angles because you're pairing next to each other. So therefore, if you say non-adjacent, the only non-adjacent angle of to AEB to angle AEB is angle CED, the angle below. So this one is AEB is paired to angle CED. That's one pair of adjacent angles. Another pair is angle AED towards the angle opening towards the left, and the angle opening on the other side, opposite of it, is angle BEC. So this is another pair of vertical angles. So for every two intersecting lines, you've got two pairs of vertical angles, two separate pairs of vertical angles. And then we have linear pair. So linear pair is a pair of adjacent angles. So linear pair are always adjacent angles. It's just that the common sides are opposite rays, meaning the non-common sides, this one forms a straight line. So you have a straight line and a line from the middle of it that goes on a different direction anywhere. Then you have linear pair. Here, there's a common side EB, but the non-common sides ED and EC does not form a straight line, so we don't have they don't form a linear pair. Okay, so this one forms a linear pair. Okay, now let's go to the math of these pairs. I mean, it's already the math of it, but the application of of these pairs. Okay, remember, our goal is to know each properties so that we'll be able to solve the problem. So how do we solve the problem? It's by making sure we are creating or we are writing a correct equation to each kind of pair of angles. Okay, so let's start with adjacent angles. Let's look at the ABC and CBD. What equation can we make for these two angles, angle ABC and angle CBD? Okay, for that two angles, okay, the equation that we can make is this. Okay, the equation that we can make is this. We can say that a measure of angle AB, ABC plus a measure of angle CBD is equal to the measurement, just like yesterday, of angle ABD. Okay, you see that? That's the equation that we can make from this. If two angles forms an adjacent angle. So if two angles forms adjacent angles, then we can say measurement of angle ABC, the small angle, plus the measurement of angle CBD, the other small angle, is equal to the measurement of the combination of the two, which is measurement of angle ABD. Okay, right? You get it? Okay, small angle plus another small angle equals to ABD. Okay, so that's how uh, how what do you call it? Interpret. That's how we interpret that kind of angle pair. If the two angles are adjacent angles, then we can make this kind of equation. Add the two angles, the smaller angles that is next to each other, then it's equal to the sum. I mean, to the bigger angle that they made together. Okay. Next, what about vertical angles? So looking at these vertical angles for each pair, AEB and CED. So AEB and CED looks like that they are equal. And that's how vertical angles are always. Vertical angles are always congruent. Okay. So we have measurement. So we can write here measurement of angle AEB is equal to measurement of angle CED. Okay, same thing with the other pair. We can say measurement of angle AED is equal to measurement of angle BEC. Okay, what else? Need that. So for each pair of vertical angles, if the two angles are said to be vertical angles, then automatically you write an equation that says that they are equal. So that's the equation that we can write. If two angles are given to be vertical angles, or if they're forming vertical angles, then you just put equal sign between them, and then you'll do the math, the algebra after that. Okay. Now, for linear pair, so linear pair are adjacent angles. So that means, what's the difference between this equation for adjacent angles to linear pair? Okay, so since linear pair form an opposite rays, the non-common side forms an opposite rays, you have a straight line. So that means then the sum of the two angles is fixed. Okay, if there's a straight line, the sum of the two angles is fixed, and that is 180. So therefore, the equation that we can write out of these two linear pairs is that measurement of angle DEB plus measurement of angle BEC is equal to 180. Okay, always 180. If two angles forms a linear pair, then we don't need to say DEC, because DEC, although it's an angle, it's another type of angle which we call a straight angle, but we don't need to write that way because you already know that if it forms a straight line, it's always 180 degrees. Okay, so let me get a screenshot and I'll post it with the video lesson. Okay, understand? Okay, now let's go to this other pair, complementary and supplementary angles. So this kind of pairs talk about the sum of the two angles. So complementary angles are two angles with measures that have a sum of 90 degrees. So it doesn't really mean that angles should be together or separated or together. They can also be separated. So angles can be together or separated as long as they form 90 degrees. Or if two angles are said to be complementary, then the sum of the two angles is equal to 90 degrees. Okay, so for supplementary, it's equal to 180 degrees. So linear pair, which we just had, are also considered as supplementary angles. Okay, all the time, all linear pairs are supplementary angles. At the same time, you can also have supplementary angles that are separated, okay, as long as their sum is 180. Or if they're given to be 180, if the sum is given to be 180, then they are supplementary angles. Okay, or if they're supplementary angles, then the sum is 180. So it just turns around that definition. So complementary is 90, complementary 90, complementary 90. Supplementary is 180, supplementary 180, supplementary 180. So what equation can we write? Simple equation. So we'll have, what can I write now? Okay, oops. Wait then. Okay, there you go. Okay, so I'll write this one is measurement of angle 1 plus measurement of angle 2 equals 90, or measurement of angle PQR plus measurement of angle XYZ, XYZ equals 90. Okay, so because they're given to be complementary. Okay, on the other hand, if they're given to be supplementary, then we'll say measurement of angle EFH plus measurement of angle HFG is equal to 180. 180. Okay, or the other one over here, it's measurement of angle M plus measurement of angle N is equal to 180. Okay, so these are the things that we need to know here. We should be able to come up with an equation that the correct equation. You should be able to write a correct equation for each given type of relationship so that we can solve the problem properly. Okay, so like what I have said, the process of solving the equation, I mean, after you replace it with makarang x plus makarang x equals 90, you should be able to know how to solve it because that's already your algebra, like what we did last time in the pretest. We're just solving the variable, and that's the main goal here. Okay, our main goal is for us to be able to come up with the right equation, because when the equation is already there, then you just need to go back to the algebra that you had, the process that you have learned in algebra. Okay. Okay. So let's check some examples here. Uh, so name an angle that satisfies its condition. Name two obtuse vertical angles. So vertical, you have to look at the two angles that, the two lines that intersect. So here we have this line and this line. It says obtuse, so it should be greater than 90. So this one is obviously greater than 90 with measurements 115. So uh, this one is paired to the angle opposite to it on the other side. So that means below it or opposite side. That means it's the combination of these two small angle because we're referring to these two lines. So this line is not part of the one that makes the vertical angle, the ray ZT. So we say V ray VZX is, and the angle VZX, angle VZX and angle YZW are vertical angles, obtuse vertical angles. And then the two acute adjacent angles. So acute, smaller than 90 and next to each other. So we can have these two angles. This is their common side. So XZW and WZT. Okay. We can also have this 65 and the 50 angle WZT and angle TZY. We can also have the 50 and the 65 to the other side. To this side, we have angle TZY and angle YZV. Okay, but that's only satisfying two acute adjacent angles. So we've got one, two, three pairs of acute adjacent angles. Okay. Okay, here. So find the measure of two complementary angles if the difference in the measure of the two angles is 12. So there are two angles. You cannot have complementary angles which only has one angle. So there are two angles. So you may draw them. Okay, that there are two angles. You don't need to be concerned about the size. This is just for illustration purposes. Okay, so we have angle A is X and angle B is not yet. So by looking on the statements here, it says that the sum of the measure of complementary angle is 90, right? Okay. So another statement here. Two complementary angles if the difference in the measure of the two angles is 12. Okay, so let angle A be X, and then because angle A and angle B are complementary, so angle B plus X is equals to 90, right? Or angle B is equal to 90 minus X. I say, so the problem states that the difference of the two angle measures is 12. So that means angle B minus angle A is equal to 12 because difference is minus. All right. So the difference of the two angles is 12. So from there, we'll have that equation that say, says angle B minus angle A equals 12. So we replace 90 minus X equals 12. 90 minus 2x equals 12 minus 90 both sides. Negative 2x is equals to 78. Divide negative 2 both sides. So negative divide negative. So x is equals to positive 39. And so the value of x is 39. And so angle A, which is x, is 39. Angle B, which is 90 minus x, is 90 minus 39 is 51. So you see, if you add 39 and 51, they're equal to 90. And that's expected because they are given to be complementary angles. And then when you subtract them, 51 minus 39 is also 12. Okay? Last, perpendicular lines. Okay, so perpendicular lines are lines that intersect to form a right angle. Okay, so if you see that when lines intersect and you see a square in the corner, that means it's a right angle. So if it's a right angle, all the rest here are right angles. This is 90 degrees angle, 90 degrees angle, 90 degrees angle. Why is that so? Okay, given that this is 90, it's vertical to the other side. So this one must be also 90 because we said vertical angles are equal, right? If this is 90, it should be its linear pair to the other side. So in linear pair, they should have a sum of 180. So if this side is 90, what should be this side so that the two becomes 180? Yes, correct. It's also 90. So 90 on over here, then also 90 over here because they're vertical angles because it's 180 to here or in 180 to here. So no contradiction there. Gives us the correct angle. So if lines are considered to be perpendicular with this symbol, then it forms 90 degrees angle. Okay, so it forms 90 degrees angle. You must be dealing with 90 if you are dealing with the term perpendicular. Okay, like for example here, find x and y so that BE and AD are perpendicular. It's asking what should be the x and what should be the y? What should be the value of the x and what should be the value of the y so that these two lines are perpendicular? So that this line BE and AD are perpendicular. So for them to be perpendicular, the angles that they form must be a right angle. So this angle here from FB and to FD or angle BFD must be together, although they're separated, they're made up of two angles. These two angles must be equal to 90 degrees. Together, they must be 90 degrees. Also, for this angle with y, with 12y minus 10, it refers to angle AFE. So, for these two lines, again, to be perpendicular, then this angle AFE must also be equal to 90 degrees. So, for the x, let's start with the x. Measurement of angle BFD is equal to the measurement of angle BFC plus the measurement of angle CFD. Okay, so we're assuming that BFD should be 90 because we want these two lines to be perpendicular. So 90 is equals to 6x plus 3x. Do the algebra. 6x plus 3x is 9x. Divide both sides with 9 to solve for x. So x is equals to 10. Okay, so x must be 10 so that these two angles will make up a 90 degrees. Okay, you see, 6 times 10, 60. 3 times 10, 30. 60 plus 30, 90. Okay, so I know you know how to do that one. And then for the y here, so let's find y. So this 12y minus 10 is referring to this whole angle here on the lower left of this coordinates here of these two intersecting lines. So it must be also 90 degrees so that these two lines again becomes perpendicular. Okay, so because they need to be 90, they need to be forming 90 degrees angle. So measurement of angle AFE is equal to 12y minus 10, right? And so this AFE must be 90. So 90 is equals to 12y minus 10 plus 10 both sides. 100 is equals to 12y. Divide 12 both sides. Y is equals to 25 over 3. Okay. Teacher, fraction. Fraction is still a number. So don't be confused as to end up with a fraction, end up with a decimal number. It's fine. It's totally fine as long as you can go back and check if it's correct. Like for example, if it's 25 over 3, so 25, 12 times 25 over 3 minus 10. So you can divide 12 by 3. So 12 divided 3, 4. So it becomes 4 times 25, 100 minus 10. Go back to 90. Still okay. Okay. So any question? Okay. So I hope it's clear. And anyways, since this is a video, you can always move back or pause and understand and then replay it and so on. Okay. So I hope you're doing fine. Uh, you'll be able to get through this situation, guys. So thank you and have a nice day ahead.